Hello Math 109 students, welcome to section 1.6. 1.6 is going to involve lots of different kinds of applications problems, and what I mean by that is word problems. Word problems are really the most important kinds of problems in math because without them, the math is really no good to the world. Word problems is where math gets applied to the world. You walk out into the world and you're walking down the road and nothing happens. It's not like something jumps out of the ditch and says 2x plus 5 equals 3, solve me. But you do run into situations in life where you need to think about things in a mathematical way to figure out a value to to build a shed or to find the best cost for something, whatever you're trying to do. And when that happens, you encounter the world through words. You see something and it translates into your mind as some sort of a description, like what I'm doing right now, talking, communication. And that we go from, so let me just get some definitions off this page. All right. To solve applied problems, we must be able to translate the verbal description into the language of mathematics. We do this by using variables to represent unknown quantities and then finding relationships that involve these variables. The process of doing all this is called mathematical modeling. All right. Mathematical modeling. So we take a real life situation and we model it mathematically. All right, we encounter some sort of a real situation, a real problem. We have a verbal description of that problem. In other words, we can communicate that problem to ourselves. This is how we think about the problem. Then we take that and put it into the language of mathematics. Then from there, we construct a problem that we can solve for the unknown. We get a solution, and when we get the solution, we check it back, make sure it makes sense with the math, with the verbal description, and with the real life situation. All right, let's see here. All right, so the first kind of problem we're going to do is interest. We're going to talk about money and interest. Interest is money paid for the use of money. So if you're borrowing from the bank, they're going to charge you for the use of their money to do what you want to do with their money. And so when you pay them back, you'll have to pay them back more than what you borrowed, and that's called the interest. All right. The principal is the amount that you borrowed in the first place. The rate of interest is the amount charged for the use of the principal for a given period of time, usually a yearly basis. This also works the other way. When you invest money, you are giving a company permission to use your money. And then you may be paid a dividend, or you maybe if the company grows, you own part of that company, and so you're going to get a rate of return for that growth. So it can work both ways. The interest formula for this is simple interest. When we get into exponential functions, we'll have a much better formula for interest. But for now, this is a simple interest formula where I is the interest, P is the principal, that's the original amount, R is the interest rate, and T is the amount of years here. So here's an example. Suppose that Juanita borrows $500 for 6 months at the simple interest rate of 9% per annum. Per annum means per year. What is the interest that Juanita will be charged on the loan? How much does Juanita owe after 6 months? Okay, let's take that information to the scratch paper where we can work on it. All right. Be a pretty simple problem. I equals PRT is our formula. And so P is the principal. What is the principal? It's the amount that she borrowed. It's the $500 that she originally borrowed. R is the interest rate. What's the interest rate? 9%. Now make sure you express that interest rate not as a percent but as a decimal. 9%. That is 0.09. Percent means per 100. Percent. Cent means 100, like century. Okay, so percent means per 100, and so you divide the 9 by 100 to get it into a decimal. Or in other words, you move the decimal place 2 places to the left to get it as a decimal. So 0.09. So 0.09 is what we put here. And we're doing it for 6 months, but the T is the years, right? So if we got 6 months, what do we put for T? We got to put a half or a 0.5. Make sure not to put 6. That's where a lot of students would go wrong. All right, calculate that. That is $22.50. So after 6 months, she owes an extra $22.50 in interest. So that answers the first part. That's the interest. The second part, how much does Juanita owe? The total she owes now is the $500 she borrowed plus the $22.50 she's got for interest. So the total that she owes is $522.50. All right, next problem. Candy has $70,000 to invest and wants an annual return of $2,800, which requires an overall rate of return of 4%. She can invest in a safe government-insured certificate of deposit, but it only pays 2%. To obtain 4%, she agrees to invest some of her money in non-insured corporate bonds paying 7%. How much should be placed in each investment to achieve her goal? Now, what I like to do is look at the last problem, the last question that is, how much should be placed, how much in each investment? That's what my variables are going to be. My variables will be what the last question is asking. How much should be placed in each investment? What kind of investment are we talking about? We're talking about the certificate of deposits, and we're talking about corporate bonds. So I'm going to say that X is the money in CDs, and I'm going to say Y is the money in bonds. So we got how much should be placed in each investment. That's going to be X and Y. X is in the CDs, Y is in the bonds. All right, now I've got to make equations with this thing based on the information given in this problem. Okay. One simple equation is based on this. She has $70,000 to invest. That's a very simple equation. That means the total investment is $70,000. That means X and Y together is $70,000. All right. The next thing that we're going to do to get see, we have two unknowns. We have X and Y. So we can't solve for two different unknowns with only one equation. So we got to get another equation from this information in the problem. That's going to come from her annual return of $2,800. All right. The annual return of $2,800. Okay, so that means that the CD interest plus the bonds interest has to equal the total interest. And the total interest we just said is the annual return. That means the total interest returned to her is $2,800 per year. Now, CD interest. You remember interest is I equals PRT, right? Well, PRT for the CDs. How much is she putting in CDs? We don't know. That's why we called it X. So the principal for the CDs is X. That's how much she's putting in CDs. What is the interest rate for the CDs? 2%. So 0.02. How much are we putting in bonds? Again, we don't know, but we've called it the variable Y. Y is the principal that we're putting into the bonds. How much do the bonds pay? What's the interest for the bonds? 0.07. Oh, I forgot about the time, didn't I? What's the time? The time is, it says an annual return. Okay, annual return. So that means 1 year. So an annual thing would be 1 year. And so the t is just 1. That's why I didn't really worry about it, because it's just 1. So we put 1 there. It won't. We don't even have to put the 1. Okay, so let me make these two equations a little neater. I've got 0.02x plus 0.07y equals 2,800. And I've also got x plus y equals 70,000. I'm going to show you two ways you can solve this, one by hand and one with a calculator. All right, one way by hand, I'm going to take this equation and I'm going to get one of the variables by itself, either x or y, it doesn't matter. I'll just get y by itself. Y will equal 70,000 minus x. So then I can take that 70,000 minus x, and since it's equal to y, I can substitute it in for y in the other equation. It's called the substitution method. So 0.02x plus 0.07 times 70,000 minus x equals 2,800. Now I'm down to one variable, so I can solve for that one variable. 0.02x plus, I got to distribute, times 70,000, that's 4,900, minus 0.07x equals 2,800. All right, now I'm going to combine my 0.02x with my 0.07x. That's going to give me negative 0.05x plus 4,900 equals 2,800. And I'm going to subtract 4,900 from both sides. Negative 0.05x equals negative 2,100. Divide by negative 0.05. And x equals 2,000. All right, now to find y, I just take that 42,000 and plug it back in for x in either one of these equations. That looks like the easiest one, or I could put it in over here, same thing. And so y equals 70,000 minus 42,000, which I believe is 28,000. All right, so there's my solutions. That means I'm going to invest 42,000 into CDs and 28,000 into the bonds, and that's going to accomplish Candy's goals with a minimal amount of risk. And that's how you think like a financial person. I'm going to show you also how you can put that into your calculator, and it can solve these things, these systems of equations for you. It's pretty cool. All right. Okay. Go to apps. And the ninth option is, for me at least, it might not be the same for you, is PLYSMLT2. It's PolySimult2. It solves polynomial equations and it solves simultaneous equations. When we have two equations, that's called simultaneous equations, or a system of equations. All right, anyway, I'm going to click number 9, and then it brings me to this menu. Polynomial root finder, we're not going to use that here, but we might use that in the future. That's a really good one. And 2, simultaneous equation solver, that's what we want. 3, 4, 5, or 6, you never need to use. I'm going to click option 2, simultaneous equation solver, and it brings me to this menu. How many equations do we have? 2, so I'm going to leave it at 2. If we had 3, 4, 5, or however many equations, it's fine. How many unknowns? That means how many variables we have, x and y. That's 2 also. All right. Do I want it to give me an automatic answer or a decimal answer? That doesn't matter. That doesn't matter. If you want it to round to a particular decimal point, you could make this say 0, 1, 2, 3, 4, whatever decimal point you want it to round to. Radians or degrees don't matter in this class. That would be more for trig. Then you have to click next. You actually can't click down to the next button. You have to. This is going to be your graph button, because that's the button under next. Like y equals would be under main, trace would be under help, graph would be under next. So you click the button under what's the option you want. So I got to click the graph button for them to hit next. All right, now my system of equations, I got to put in a number in front of the x, a number in front of the y, and a number on the other side of the equal to sign. Well, for one of my equations, it was just x plus y equals 70,000. So I'm going to say 1's in front of that x, enter. Plus 1's in front of that x, enter. And on the other side of the equal to sign, I have 70,000. Ooh, that's too many. 70,000. Now the other equation was 0.02 in front of the x. It doesn't matter which equation is on top, which is on bottom. The plus was there, and then 0.07 was in front of y. And I can't remember, what was it, 4,800? No, 2,800. And 2,800 was on the other side of the equal sign, 2,800. And then you just click solve. Again, you have to click the graph button because that's the button below solve. And it tells you your answers. So that's the way to do it in the calculator. I had to set up your equations correctly. But once you got the equation set up, you could let the calculator help you after that. Next, we've got something called mixture problems. All right, here's the mixture problem. The manager of a Starbucks store decides to experiment with a new blend of coffee. She will mix some B-grade Colombian coffee that sells for $5 per pound with some A-grade Arabica coffee that sells for $10 per pound to get 100 pounds of the new blend. The selling price of the new blend is to be $7 per pound, and there's to be no difference in revenue from selling the new blend versus selling the other types. How many pounds of B-grade Colombian and A-grade Arabica coffees are required? So I'm going to let, again, my variables are going to be what the problem is asking. I'm going to let variable A represent the Arabica, the A grade Arabica. I'm going to let B represent the B grade Colombian. So the pounds of that and the pounds of that. All right, now I've got to come up with some equations with A and B in it based on the information in the problem. Well, one would be simply this, 100 pounds. She wants 100 pounds of the new blend. That means what? The total pounds, the A pounds plus the B pounds must equal 100. There's one of my equations. All right, what's another equation I can get based on the money? All right, Colombian is 5 per pound. Arabica is 10 per pound. We want our new blend to sell for 5 per pound, and there's to be no difference in the revenue from the new and the old. So that means the revenue of Arabica plus the revenue of Colombian needs to equal the revenue of new blend. So what's the revenue from the Arabica? Well, it gets $5 per pound. And how many pounds of Arabica are we talking? That's what we called A. I've got that wrong. The Arabica, sells for $10 per pound. The Arabica is $10 per pound, and the how many pounds of Arabica are we talking? We're talking about, we gave that the variable name A. We don't know, but we called it A. A is the pounds of Arabica. What does the Colombian sell for? $5 per pound. And how many pounds are we talking? Well, we don't know. That's why we called it letter B. B represented the pounds of the Colombian. And how many, what's the revenue from the new blend? Well, it's $7 per pound. And how many pounds are we talking? Well, we have already said that it's 100 pounds of the new blend. So 7 times 100. All right, let me clean that up. That's going to be 10A plus 5B equals 700. Now, once again, I could solve this by hand by doing substitution, like as I showed you in the previous example, but I'm just going to go to the calculator and do it that way. So I'm going to go back to the main menu. So I'm going to hit Y for that was under main. I'm going to hit option 2 again. I've got 2 equations, 2 unknowns. All that's going to be the same. I click next. This time, I've got one in front of the A, one in front of the B, and 100 on the other side of the equal sign. That was one of my equations. For the next equation, it was 10 in front of the A, and it was 5 in front of the B, and it was equal to 700 on the other side of the equal sign. Then I click solve, and there it is, 40 and 60. So A equals 40, and B equals 60. There's my blend. 40 pounds of Arabica, 60 pounds of Colombian. All right, next kind of problem is uniform motion. Okay, our next kind of a problem is a bit of a physics application. We're talking about uniform motion. Uniform motion. Uniform motion is when something is going at a constant speed. All right, and when something is going at constant speed, then you may know this from physical science if you've taken that before, that speed equals distance over time. Or you can rewrite that, if you multiply by time on both sides, you can get the speed times the time equals the distance. Or if you divide both sides by speed, you can get time equals distance over speed. Now, all those are the same exact formula, just rearranged. And maybe different ones of those would come in handy for different problems. All right, so we're going to try to apply that to this problem here. All right. Tanya, who is a long distance runner, runs at an average speed of 8 miles per hour. All right, let me write some stuff down. Tanya, speed equals 8 miles per hour. Speed for Tanya. All right, 2 hours after Tanya leaves your house, you leave in your Honda and follow the same route. If your average speed is 40 miles per hour, so I'm going to write that down, speed for the Honda is 40 miles per hour. How long will it take before you catch up to Tanya? How far will each of you be from your home? Okay, so I'm going to do Tanya's distance and see how that works. Distance for Tanya equals the speed for Tanya times the time for Tanya. All right. I don't know the distance for Tanya, so I'm going to have to leave that as a variable. The speed for Tanya I do know, that's 8. The time for Tanya I don't know, so I'm going to leave that as a variable as well. Now notice my variables are D and T, and those are the same variables that I'm being asked to find. How long will it be? That's the time. How far will you be? That's the distance. So my variables are are based on what the final questions in the problem are asking me to look for. Now I'm going to do, but I have 2 variables, so again I need another equation. So I'm going to do the distance for the Honda. That's the speed of the Honda times the time for the Honda. Do I know the distance for the Honda? I do not. Do I know the speed for the Honda? I do. It is 40. Do I know the time for the Honda? I do not. Okay. Now, I don't like the fact that I have introduced, even though the variables are D and T, they are different than the D and T in the other equation, because those are for Tanya and these are for the Honda, and they might not be the same. So what I need to think about now is maybe how the Honda time and the Tanya time relate to each other, and also how the two distances may relate to each other also. All right. Remember that the Honda left 2 hours after Tanya. So I think that means that T sub H, the Honda's time, is equal to Tanya's time minus 2, because the Honda has been going 2 hours less than Tanya, because Tanya started 2 hours before. So Tanya's time is 2 hours more than the Honda. All right. So the Honda's time is 2 hours less than Tanya's. All right. So that will allow me to substitute this into there so that I won't have two different time variables. Let me do that now. D sub H equals 40 times T sub T minus 2. All right. So now I'm down. I've got two variables. Next, I've still got three. But here's the other thing. How do the distances relate? How does D sub H, the Honda distance, relate to the Tanya distance? Well, it says, how long will it be before you catch up to her? What are the two distances when you catch up to her? When you catch up to her, the distances are what? They are the same. So these two things are the same when you catch up to her, which means I can set this and this equal to each other because they are the same. I can set the two distance equations equal to each other. So 8t equals 40t minus 80, because I just distributed the 40 here. So now I can solve for t. I'm going to move the 40t over. That gives me negative 32t equals negative 80 divided by negative 32. T equals 80 divided by 32 equals 2.5. 2.5 what? Hours. 2 hours and 30 minutes. That is Tanya's time, because that's the variable we ended up with. All right. So the Honda's time, it's really not clear what it asks when it says how long will it be before you catch up to Tanya. Tanya's been running for 2.5 hours, but I think what it wants us to say is, since Tanya's been running for 2.5 hours and we left 2 hours after her, then how long were we actually driving before we caught up with her? So the time for the Honda, remember, is the time for Tanya minus 2. So that's going to be 2.5 minus 2. So we've only been driving for 0.5 hours, a half hour. I think that's what it really is asking us. And then it says, how far will each of you be from your home? Well, we can put that into there, this half hour in for the time for the Honda, or we could put 2.5 in for that. And we'll get the same answer either way for Tanya and for the Honda. So if I put a half hour in here, I'm going to get 20. D sub t equals 8 times 2.5, or we could say D sub h equals 40 times 0.5, and either way we get 20. 20 is 20 what? 20 miles. We're 20 miles from home. All right, and that does it for that one. Let's go to another problem. Next problem. A motorboat heads upstream a distance of 24 miles on a river whose current is running at 3 miles per hour. The trip up and back takes 6 hours. Assuming that the motorboat maintained a constant speed relative to the water, what was its speed? Sorry, so in this case, a motorboat goes upstream 24 miles and then goes back downstream 24 miles, but it was going slower upstream and faster downstream because of the current of the river. We're fighting the current going upstream, and the current's pushing us faster than than our motor can go when we're going downstream because it's going for us. It's like if you run up the down escalator, you're running slow. If you run down the down escalator, you're going faster. All right, so I think what I'm going to say here is I'm going to say that the time, because it gives me a total time, I think that's why I want to use time here. The time, because it gives me a total time, upstream plus the time downstream equals the total time. The total time is 6. All right, the time upstream. Remember this? We said one way you can set up the equation is t equals distance over speed. So the distance upstream is 24. Now the speed upstream is going to be the speed of our boat minus the speed of the current, because the current is subtracting from our total speed. So what is the speed of our boat? We don't know it. That is the variable we're trying to find. What is its speed? That's what we're trying to find. So that's going to be x. So x is the speed of the boat. But when I'm going upstream, I'm going to subtract 3 from it because the current is making me slower. And then going back downstream, what's my distance? It's again 24. Same distance back downstream. What's my speed going downstream? Well, it's the speed of my boat, but this time the current is making me faster. So it's plus 3. So it's like if I'm running, imagine I'm running on top of a train, and I'm running 10 miles an hour. If I'm running 10 miles an hour on top of the train, and I'm going in the same direction the train's going, and the train's going 20 miles an hour, then the speed that I'm going relative to an outside observer is 30. They're going to see me going 30 miles per hour because it's going to be the 10 that I'm going plus the 20 that the train's going. That's going to be my total. And if I'm running backwards, the opposite direction from the train is going to subtract. So if I'm running 10 miles an hour backwards, but the train is going 20 miles an hour forward to an outside observer, I'm actually going to be moving negative 10 miles per hour. In other words, I'm moving the direction of the train by 10 miles per hour because the train's speed is that much faster than my speed. Okay. So now I have to solve this equation. All right, what I would do here, this is a rational equation. Now from here, what you could do is you could solve this in your calculator. Again, put the left side on the y1 and the right side on the y2 and find the intersection. That would not be a bad idea. But if I wanted to solve it by hand, I would first, all these terms are divisible by 6. I'm going to divide the whole thing by 6. Every term is going to get divided by 6. That's going to make all the numbers smaller. So that's going to be 4 over x minus 3 plus 4 over x plus 3 equals 1. Okay. And now what I will do is I will multiply everything by x minus 3 to get the x minus 3 off the bottom. And that's going to give me 4 plus 4x minus 12 over x plus 3 equals x minus 3. Now I'm going to multiply by x plus 3 everything in order to get the x plus 3 off the bottom. It's going to cancel out x plus 3 on the bottom there. That's going to give me 4x plus 12 plus 4x minus 12 equals x squared minus 9. All right, the plus 12 and the minus 12 cancel, and I get 8x when I combine the two 4x's over here. I'm going to move my 8x over. I'm going to have x squared minus 8x minus 9 equals 0. That was me moving my 8x over there. All right. Now factor it. X minus 9, x plus 1. So x equals what? 9 and negative 1. Now what does this represent? What is x talking about? The speed of the boat relative to the water. So negative 1 would not even make sense as an answer. It makes sense on paper with the math, but not in the real life situation of the context of the speed of the boat. But x equals 9 is a good answer for that. And finally, we have a problem that is about rate. So it's a whole lot like uniform motion because you're going to constant rate in uniform motion too. All right, let's read the problem. At 10 a.m., Danny is asked by his father to weed the garden. From past experience, Danny knows that this will take him 4 hours working alone. His older brother, Mike, when it is his turn to do the job, requires 6 hours. Since Mike wants to go golfing with Danny and has a reservation for 1 p.m., he agrees to help Danny. Assuming no gain or loss of efficiency, when will they finish if they work together? Can they make the golf date? All right, Danny's rate. Let me do it like this. The speed of Danny is 1 garden in 4 hours. Or we could write that as 1/4 garden per hour. All right, the speed of Mike is 1 garden in 6 hours. Or we could rewrite it how? 1/6 of a garden per hour. Now they are, let's do it like this. Danny's speed plus, you kind of got the feel for it now, don't you? Danny's speed plus Mike's speed equals total speed of doing the garden. All right, so, and when I say speed, speed and rate are the same thing. Danny's speed is 1/4. Mike's speed is 1/6. And the total speed is 1 garden over what I'm looking for. I'm looking for the time it takes for both of them to do it. Instead of saying total speed, I could say combined speed, which I guess is the same thing. And I don't know the time that it takes to do a garden when both of them are doing it together, but that's the variable that I have because that's the variable I'm looking for. Right? When will they finish? That's what I'm looking for, the time. So I'm adding these fractions here. 1/4 plus 1/6. Got to get a common denominator. I'm going to multiply this by 2 over 2 and this by 3 over 3 to get a common denominator. So that's going to be 1/12 plus 2/12. I'm sorry, that's 3/12 plus 2/12. That's 5/12. All right, so 5/12 equals 1 over t. All right. Now, I could take you through a more thorough process, but I'm going to kind of give you a shortcut here. You can just do the reciprocal of both sides when it's like this. I can flip both sides. When I have an equal to sign like here, and I have this variable on the bottom I'm looking for, I could flip both sides. So 12/5 equals t over 1, or just equals t. 12/5 is the same thing as 2 2/5. 2 2/5. How long is 2 2/5? Let's think about that. That's 2 hours and 2/5 of an hour. How many minutes is 2/5 of an hour? Well, what's a fifth of an hour? 60 divided by 5 is 12. So a fifth of an hour is 12 minutes. So 2/5 of an hour would be what? 24 minutes. So 2 hours, 24 minutes. When will they be finished? If they work together, it'll take them 2 hours and 24 minutes. All right. If it wants to know what time that would be, if they started at 10, then that would be 12:24 p.m. They started at 10 a.m. And the last question is, can they make the golf date? Well, what time's the golf date? 1 p.m. So depending on how far it is, if it's not that far away, I think the answer they're looking for is yes. They can make the golf date. All right. That finishes us up for section 1.6 with all these word problems. Good luck to you on this assignment, and I'll see you again in 2.3.